Okay, good morning, ninth grade. Sorry, here I am. The video started sooner than I thought it was going to. Anyway, I hope you guys are doing well today. Just to give you a little bit of a heads up for what we're going to be doing with the next couple of weeks as far as physical science goes. This week and next week, we are going to finish up section 3 of your class notes. Section 3 is a little bit longer. Originally, I was going to try to do it all this week, but then I decided to break it up, knowing that you had the Life of a Scientist paper to work on as well. So we are going to finish section 3 between this week and next week. Also, next week, your study sheet for your final exam will be coming home to you, okay? And that is going to count for a quiz grade when you come back to school the following week. I'm going to check it, I'm going to go through it, make sure that you guys have the right stuff, that you're studying what you need to be studying, and we will be reviewing for the final that week. I don't know what day the final is going to be yet. I haven't gotten that much information at this point in time, but that's kind of where we're going, what we're doing, so hopefully you guys can get on board. If you have not been taking notes, I would highly recommend that you go back and watch videos and take notes, because it is going to be difficult to fill out that study sheet without them, okay? Because sometimes the terms are in the textbook, yes, but I write the test off of your class notes, not off the textbook. So if you might have a correct answer, but not the answer I'm looking for because you don't have it in your notes, okay? So, Section 3, using electricity, day-to-day uses. What do we do with electricity? That's basically what this is going to look at, okay? So, light from electricity, the incandescent lamp. Now, this is the first electric lamp that was suitable for household use. There had been others that had been created, that had been worked with, but none of them were safe enough to be used in a house until the incandescent lamp came along. This produces light by heating a thin piece of wire known as a filament to a very high temperature. It was perfected by Edison in 1879. It had been used before Edison. A lot of people like to say Edison invented the light bulb. That's not entirely true. Edison came along and he took other people's work and he perfected it, but he didn't necessarily invent it himself, okay? At least with the light bulb. And there are varying opinions on Edison as a scientist in the science world. You can look it up and read that on your own time if you want. But the original used a carbon filament. Today, modern ones have a tungsten filament. The carbon filament would burn very quickly, and it wouldn't be useful for a very long time. So they did a lot of work with the filament to get it to the tungsten filament, which now allows us to use light bulbs over and over and over again for an extended period of time. And then modern lighting bulbs are filled with argon or nitrogen to make the filament last longer. The fluorescent lamp, okay? This produces light by passing electric current through a long tube filled with a low pressure mixture of mercury vapor and argon, okay? The lights in the classroom, okay, those long bulb lights, those are a fluorescent lamp bulb, okay? Now, phosphor is the material that glows when it's exposed to radiation. So what happens is fluorescent lamps are actually coated with this phosphor on the inside, right? And it allows them to glow brightly when struck by a UV ray. So as the ray is passed through the fluorescent lamp, the phosphor heats up and it starts to glow, and that's why the lights, when you turn them out, there's sometimes still a persistence of light. It's because that phosphor is cooling down. It's losing the heat, so it's getting rid of the glow. All right. Some other light forms that you're common with, LEDs, you should be very familiar with. We use them a lot in today's world. All right. The compact fluorescent lamp, or CFLs. These are coiled tubes that operate the same way long tubes do, but they can be used in sockets designed for incandescent bulbs. These were the forerunners of LED light bulbs. Then you have the neon lamp. This is an electric discharge lamp filled with neon gas instead of mercury vapor. Any type of neon sign runs off of this technology. And then light emitting diodes, or LEDs. These are semiconductor devices that emit light when a direct electric current is applied. LEDs are pretty much, they've pretty much taken over the market as far as lighting goes. People are always looking for LED lights, working with them. They're brighter than a typical traditional light bulb. They burn longer, things like that. So they've pretty much taken over the market, but the incandescent lamp and CFLs have not gone away completely. They still exist. You can still go to Lowe's or Walmart and buy them. Sorry. All right, motion from electricity. So this section of your notes is going to look at devices that move or have moving components because of electricity. All right. So a solenoid. This is a simple device that converts electricity to back and forth motion. It consists of a wire coil with an iron bar free to slide back and forth. The best example of this that I could think that you guys could relate to would be an electric door lock, okay? Or even like electric gates in gated communities. You have to have that code to get in. Well, that code slides that bar. That code initiates an electric current that hits the wire, that slides the bar, allowing the gate or the door to open. And then when it closes, it automatically shuts and locks everything back up again. The telegraph. Okay, now the telegraph, it's not used very much today at all. Okay, you might find some people who really enjoy the older technology, so they will use them, or you might find them in reenactment camps or reenactment place. But the telegraph kind of paved the way for using electricity in communication. Okay, like I said, it's not used so much today, but it was the granddaddy. All right, it paved the way. It did the hard work. Okay, so the telegraph is a device for communicating over long distances by means of electromagnets. It consists of a switch or a key at one end of a long wire and an electromagnet at the other end. All right, the key is where the message. Oh, excuse me. Sorry, guys. Where the message is sent out from, and the electromagnet is where the message is received. Okay, and they communicate via Morse code, which is a series of dots and dashes over the telegraph. Each dot, each dash stands for a number, a letter, and you combine them to get words and sentences and all of that. You have a relay, which is an electrical switch operated by an electromagnet. Relays, a good example of this would be at a train station. The button that causes a track to switch, okay, if you've ever seen videos of two tracks, but they're connected and they flip a switch and one connects and the train goes a different way than it originally was. All right, that's a relay. And then loudspeakers, any type of microphone usage, anything like that falls into this loudspeaker category. But it's a device that converts pulses of electricity into sound waves. So that's where we're going to stop for today with your notes. I think that's it. Yeah, C is where I want to stop. So that's where we're going to stop for today with your notes for physical science. That's all your notes that you're going to have this week. Like I said, next week we will pick up with letter D and move forward from there. I hope you guys are doing well. I miss you, and I'm praying for you.